Welcome back to our second session on technology for management. This is Dr. Swapna. So today let us look into analog, digital and binary languages. Just the basics of it. Analog and digital signals are used to transmit information, usually through electronic signals. In both these technologies, the information such as any audio or video is transformed into electronic signals. So here analog signal is a continuous signal which represents physical measurements, whereas digital signals are discrete time signals generated by digital modulations. So for example of analog signals, the human voice is also an analog signal. The watch that is displayed here, this is the analog clock. For digital devices, you can take computers, CDs, DVDs and any other radically, even watch also you get as digital watches. So before going to our actual differences, I would like to show you a small video. Please have a look at it carefully.
I tried my best to study, but I really don't understand things. What is this analog and digital signals?
Oh, Mary, you took a complicated topic to study on your own. Don't worry though. Today, the Einstein mouse has all the answers for you.
Oh yeah, right.
See, Mary, analog signals are continuous flow of electricity. For example, take this light bulb. If I keep playing with the dimmer, it is a continuous increase and decrease in the light of the bulb. Oh, so that's why analog signals are shown in waveform, where if this is light and this is dark, then these are infinite small changes to the intensity of light. Absolutely right. You are smarter than you think. Now, if I switch the light on and off like this, it is similar to a digital signal, where the signal has only two values, on or off.
Now I understand.
This means in digital, this is on and this is off.
So the graph represents only two values, one off and the other on.
Precisely, Mary. Now I hope you understand. Get back here, mister. I have understood by a long shot.
So why does it make so much of a difference whether things are analog or digital? And you said you can explain. So please do that.
Okay, calm down. You see, Mary, nowadays most electronic devices work on digital signals. Computers are the best example of this. Computers work on electricity, and digital signals define all computing processes in a on-off system. You might have heard of computer language, binary, using 0 and 1.
Yeah.
Well, there. 0 means off and 1 means on. So this enables the computer to use digital signals to run all of its operations.
So where are analog signals used?
Mary, pay attention. I am telling this for you.
Sorry, the music was so nice.
See, Mary, anything that has continuous change is analog. This gramophone, for example, is an analog device. Sound from gramophone has all frequencies, so it is an analog device. So have you understood now?
Yes, it's a little better. But why aren't all devices analog?
Digital has many advantages over using analog systems. I will tell you some major differences. Imagine a photocopier. Take a copy of a photo, then take a copy of the copy, and then continue taking copies of the copies. As you will notice, the quality of the image will keep becoming worse as we take more copies.
Why does that happen?
What happens is that most analog signals carry a lot of unwanted data with them. As we replicate it, the noise becomes more and more, and the quality of the image goes bad.
Yes, so when we take a lot of copies of a photo from a computer, that doesn't happen because the file is digital and unwanted data on it.
and so it doesn't have any unwanted data on it. Absolutely, Mary. So, Teri, now digital is everywhere. Cell phones, calculators, music players, TVs, and even cars. Yes, Mary. In some cases, though, analog offers excellent quality and therefore is still preferred over digital format. Like where? Like in filmmaking, many directors still prefer using analog films over digital formats, as they feel films give them a larger color depth and clarity over digital. But digital technology is also catching up fast.
So hoping that the video was a bit useful, let us continue with the differences of analog and digital. Please make a note of these differences. First, coming to the analog signals. So analog signal is a continuous signal which represents physical measurements, whereas digital signal are discrete time signals generated by digital modulation. Then coming to waves, as shown in this diagram, digital signals are denoted by sine waves, whereas analog signals are denoted in sine waves, whereas digital signals are denoted in this square form. See, either this one and this one. So analog uses continuous range of values to represent information, whereas digital uses discrete or discontinuous values to represent information. So coming to the next difference, analog technology records waveform as they are, just like this, whereas digital technology samples analog waveforms into a limited set of numbers and records them. These numbers are called binary numbers, wherein binary numbers contain only these two values, 0 and 1. Binary numbers are always represented by 0 and 1. When it is based on flexibility, analog hardware is not so flexible, whereas digital hardware is flexible in implementation. When you think about usage, analog can be used in analog devices only, and it is best suited for audio and video transmission, whereas digital is best suited for computing and digital electronics. Then the digital analog applications, for example, you can think about the thermometers, whereas for digital you can applications like PCs, your personal computers, DVDs, then digital clocks, digital watches, etc. Analog signals are stored in form of wave signals, whereas digital signals are stored in the form of binary bits, that is nothing but this kind of bits, 0 and 1. Analog are low cost and portable, whereas digital cost is high and not easily portable. So at last you can always give some examples like for analog watches, analog wall clocks and thermometer, etc. Whereas for digital you can say as PC, all these digital electronic devices, then CDs, computers, DVDs and so on, tape recorders and etc. So this completes your basics of analog, digital and binary languages. So let us with the next topic, computer languages. So before starting with our next topic, I would really suggest you all to go take a small break and pause my video, and then after 5 minutes to come back and then continue. And please don't forget to make notes out of these. I hope you all have taken a small break of 5 minutes, so welcome back with your refreshed minds. So coming back to our computer languages, one man communicates with another in a language which another man can understand. Similarly, man communicates, and of course that is the language. So similarly, when man communicates with the computer in a language which a machine can understand. Okay. So this language, which consists of a set of commands understandable by computer directly or after translating, it is known as computer programming language. So how does it going to translate? Again, there are translators which we'll be studying in our further classes. Okay, so let us first continue with this. And there are this computer programming language can be categorized into four types, which are low level languages. And these low level languages were basically in first and second generation language, and this high level language which was in third generation language, then user friendly languages in fourth generation language, and object oriented languages which we are following now, that is our fifth generation languages. Now first one is low level languages. So in early days of computers, only those languages were used for programming which could be directly executed on computer. Languages which computer can understand directly and are machine dependent, which are called as lower level languages. For example, machine language and assembly language are two very important low level languages. Machine language is one of the oldest and most difficult of all the languages. It is also known as first generation language. So in machine language, all the instructions were given to computer in binary digits only, and hence are directly understood by the computer. On the other hand, assembly language is easier than this previous machine language, and it is known as second generation language as well. So in assembly language, instructions are given using mnemonic operation codes, such as how can I say, see, for addition you just write ADD, and for multiplication you just write MUL, for subtraction you just write subtraction. See, mostly even many times when we are also calculating, we just write add, SUB and all. So these are all are nothing but these are machine languages. So okay, instead of binary codes, we started using these languages instead of these binary codes in assembly languages. Yeah, and of course C is mentioned on here. Sorry. Low level languages are used for development of system software, as they are not used for application developments. Managers or application programs do not need to learn these languages. Okay, next going on to next slide, which speaks about high level languages. Okay, so coming back to high level languages, development of applications using low level languages actually require a very deep understanding of the hardware system. So in order to facilitate the programs in order to facilitate the programmers to write all these programs without knowing the internal details of the computer components, many languages were developed. These languages were used commonly as English, commonly in English words, and were translated into low level languages before processing by the computer. So these languages which computer cannot understand directly and are not machine dependent. So these are called as high level languages. Such languages are also known as third generation languages. So some of the examples of high level languages are basics. Probably you would have learnt in your school level, like basic, which is called as beginners all purpose symbolic instruction code. Then COBOL, which is common business oriented language. Then Fortran, formula translator. Then Pascal. Pascal is actually name of a scientist. Then C. So C is one of the very powerful language for development of both system and application softwares. But of course C doesn't stand for anything. They've just named it C. So however, all these languages were widely used for application developments, but most of them are outdated nowadays due to popularization of fourth generation languages. So whatever that have been mentioned in the right hand side are the uses, and they are also the advantages of the languages mentioned down here. Okay, so in continuation, the next slide is user-friendly languages, which are also called as fourth generation languages. So even though high-level languages are simpler to codify than low-level languages, they still require a lot of time to learn their programming syntax. So hence these languages are beyond the reach of many computer users. So including even MIS professionals. What do you mean by MIS? MIS is Management Information System. So wherein you actually do not need any expertise in programming. So you can yourself design your requirements, needs, and you can develop your softwares. So therefore a new category of languages have been developed which are very user friendly, very easy to codify and simplest to learn. These languages are called as user-friendly languages and popularly known as fourth generation languages. See, most of the times you do your settings in your phones, right? So actually they also do fall as user-friendly languages. Same way, even softwares or when you're designing these Excel sheets, you define the column, you name the column. Okay, and you can also define each cell what function it has to do. So these all come under user friendly languages because you are setting up your requirements, your needs. So and finally what outcome you need, so it will be generated. So same way nowadays whatever softwares you are getting like MIS or HRIS or this SPSS and all, you can design your own softwares based on the requirements. So to name a few, some of the very commonly used fourth generation languages can be the base, then Foxbase, Foxpro, MS Access, Oracle, then Ingress. So and the list continues. So same way the uses of some of these softwares are mentioned here. Please go through it very carefully. Then going on to the next slide which speaks about object-oriented languages. Just a second please. Object-oriented languages, which is also called as fifth generation language. So as we had discussed that the object-oriented programming is the latest approach in programming, the languages which are based on object-oriented programming approach are called as object-oriented language. So they may be classified as fifth generation language. Object-oriented language are specifically useful for development of GUI. What is this GUI? GUI is nothing but graphical user interface. Please make a note of GUI because many times this alone is asked for examination. So what is GUI? GUI is graphical user interface applications. Okay. Then these languages are also offer a unique feature of reusable codes. So some of the popular object-oriented languages are C++ and COBOL, Pascal, Java, and I hope you have heard about all these languages. Okay, and of course again these are some of the uses of these mentioned languages. Please have a look at it. So as we all know, English is not at all a machine language, and directly the computer cannot understand the English codes, whatever you are, English language, whatever you are speaking out. So when you are giving some commands in English, you actually need a language translator. Okay, this language translators help whatever we are giving the inputs in our understandable language. It helps to translate in computer language or machine language, and the output again is translated to our understandable language, and then it is generated, given out. Okay, so these language translators also play a major role in computer devices. So, regardless of programming language use, except these machine language, the symbolic instructions have to be translated into a form that can be executed by the computer. The software which converts the codes of other languages into machine codes are collectively called as language translators. Again, this is one of the very important topics for exam point of view. So these language translators can be categorized into three types called as assemblers, interpreters, and compilers. So taking out the first one, assemblers. Assemblers translate the assembly language code, which is the source program, into the machine language code, that is the object program. After assembling, a linker program is used to convert the object program into an executable program. So the Microsoft assembler program, which is also mostly called as MASM, and Borland Turbo Assembler program, which is TASM, probably you would have heard, you would have been familiar with TASM, are the two popular assemblers. Assemblers are used mainly in development of system software. Next, coming to interpreters, instructions of the high-level languages are coded in many statements. So at the time of their execution, they are converted into machine code statements by the code statements by the statement by using the system software called the interpreters. For example, what I can give, for example, the programs written in the basic language are executed by using interpreters. Programs written in some fourth generation language, like I had mentioned previously about the base, plus are also executed using the base interpreter. There is also the base interpreter as well. So there are certain disadvantages of interpreters, as instructions are translated and executed simultaneously using interpreters. They are very slow for executing large programs. Hence, interpreters are not suitable for most of the application developments because they tend to become very slow. Like how internet also happens, because internet also works like this. When many people are using, the server becomes very slow. Okay. Next, coming to compilers. In contrast to interpreters, compilers provide faster execution speed. Compilers do not translate and execute the instructions at the same time. They translate the entire program into machine code using linker. The object code is again converted into executable code. Then compilers are widely used in translating codes of high-level languages. For example, COBOL or Fortran or Pascal and Quick Basic or Microsoft C and etc. So, and fourth generation languages as well, like Fox Pro and so on. As compared to interpreters or assemblers, they are preferred in development of application softwares. And this is a graphical representation of whatever I have explained now. Please have a look at it listening to the previous video. Okay, so thank you guys. Have a good time, have a good day, and wait for my next session very soon. Okay, have a great day. Bye bye. Don't forget to like and subscribe.